Bismillahirrahmanirrahim. Assalamu alaikum. Now we are going to talk about unit 5, which is having the topic of the open channel flow. If you remember in the beginning of this course, we talk about the different flow conduits and the channels in which water can be transported from one point to another point. One was the in we discussed in the chapter number unit number 4, which was the pressure conduit, yani piping system mainly. Here we are going to talk about the open channel flow. The open channel is a conduit which is open to the atmosphere. It is not covered, or it is if it is a pipe, then it is partially filled. It is not completely filled. So this is called the open channel flow. In this type of the channel, the flow is open to the atmosphere. So open channel flow can be called as the gravity flow. So in the open channel, the important thing that it is under gravity. Flow is under gravity. You cannot flow the water from bottom to the top. It flows due to the force of the gravity, and there will always be a free surface in the open channel, which is open to the atmosphere. And position of the free surface may change with the distance and with the time. For example, like a river, the height of the water level will change with respect to the distance in the river, or at any point with time it may change. There are different type of the example, like the river, stream, canal, flume, ditch, or culverts. These are the example. uh, the shape of the channel could be a rectangle, trapezoidal, circular, and triangular. And this also uh, can be divided into different type of the materials also. This is a one of the section, which is the trapezoidal. Here you can see that there is a side slope, and there is a bottom width, and there is a top width, so water can flow in this cross section. It will provide ease in the flow. It could be a rectangle also, like just a box, and it could be a triangular also. There could be many shapes. Here the y is the depth of the flow, yani the height of the flow, and t is the top width. You can see that this is the t, and p is the wetted parameter. If you remember, we talk about the wetted parameter. This is the length of the water, the length of the channel which is touching with the water. This length plus this length and this length, right? So this is the wetted parameter. Area of the flow is the area of the cross sectional section in which water is flowing. It is not the area of the section. The channel may be up to this height, but the water level up to this height. So this area where the water is flowing, this is the area of the flow. Hydraulic radius can be calculated by just dividing A by the P. So this is one of the parameter which we use in the calculation of various things. D is called the hydraulic depth. It is also simply the area of the flow divided by the top width. So these are the some of the parameter which we need in our calculation. When we see the section of this channel, the water is entering from here. It is flowing due to the gravity on a slope of the channel. So this is called the slope of the channel, and this is the slope of the side of the channel. This slope is different than this one. This is for the side of the channel, and this is the slope of the channel itself. The water is because it is flowing due to the gravity, and the depth can be changed, and at any point the velocity can be changed at any point, and yani the q will remain same. Classification in the open channel, say similarly like in an river or any other open channel type of the flow. There could be a uniform flow, which is also called as the normal flow, in which depth is constant at every section along the depth of the channel. It's very smooth flow. There is no change in the height of the water, then it is uniform. Generally, it is not a common thing. Non-uniform flow, it is the most common type of the flow when the depth changes along the channel. And it could be non-uniform flow can be classified into the rapidly varied flow and gradually varied flow. Rapidly varied flow, when the water change suddenly, the depth change suddenly. For example, water is coming from the top of the hill. The height of the water at the top of the hill is different than the height of the water when it is falling down. So the distance of the surface from the bottom of the channel is changing very fast. Gradually varied flow, when there is a smooth slope, then the depth of the water may change slowly. In order to solve this kind of the problem of the open channel, we generally use three type of the equation, three type of the laws: the continuity equation, which is also called the conservation of mass equation; energy equation, which is the Bernoulli's equation; and momentum equation. But in our case, according to our syllabus, these two type of the equation are sufficient to solve those problems. The continuity equation simply saying that if there is a pipe, whatever the Q is discharge is entering in the pipe, it will leave the pipe. It will not any decrease or increase, because whatever the mass entering in the system, it will go out of the system. And the Q is the discharge, which is also can be explained by the velocity into the area. The velocity, the unit of the velocity is meter per second, and the unit of area meter square. So it will become meter cube per second, and this is a unit of the cube. So this is called the continuity equation. It is saying that at any point the Q is same in a open channel flow, right? This is applicable. Another thing, if you see the Bernoulli's equation, energy equation, same equation you can apply in the piping system and as well as in the open channel. Here you see this, you can see that there is an open channel having this slope and water is flowing. This is the surface of the water, and water is flowing in this way. The depth of the water here is y1, here it is y2. It can be changed, right? And the velocity may be different here, velocity may be different here, right? The depth here is z1, and is this height of the bottom of the channel, and here it is different. So if you apply the Bernoulli equation in this situation, you can say that the height at point 1 plus the pressure head at point 1 plus the velocity head at point 1 equals to the height and pressure and the velocity head at the point 2 plus the head loss. The head loss, you remember, whenever there is a friction and there is a gravity, then there is a head loss. So if you want to calculate the total energy between 2 points in the open channel, then you can calculate all the heads, pressure, elevation and velocity head, plus the same here also. These two will be same. These two will always be same. The sum of all the energy will be same until unless you add here the energy loss, because this energy loss is because of the friction. So the total will be same. You can see from here z1 here is more, but here is small. If y1 here is more, it is maybe small, but here velocity head is very small, but here velocity head is too much, right? So but some addition of this, all the energy will remain same. Energy coefficient, which is shown in the previous equation, that this is a coefficient actually. You know, in a channel, the water is flowing with respect to depth. If you see, this is, for example, there is a bottom. For example, this is the bottom of the channel, and it is the surface of the channel. The velocity here may be slower than the velocity here, because it is near to the surface, which is sticking to the surface. So the velocity is changing with respect to height. So in order to make the average velocity, this alpha is introduced in this equation. This velocity, it is not the velocity at different points. You cannot use the velocity at the bottom separately and at the top separately. So to take the average of that coefficient is introduced. So this a term is associated with each velocity head, alpha, the energy coefficient, right? And this term is needed because we are using the average velocity over the depth of the to compute the total kinetic energy. So this alpha is showing that it is an average velocity. Uniform flow computation, when we do, then we have to do some calculation to calculate the depth, the Q, the discharge, the area of the flow, the velocity at different section. So these are the things generally we calculate. So the equations are there to calculate this value. And uniform flow generally is not common. It is rarely occur in the nature. Most of the time there is a non-uniform flow. The depth is changing all the time. So the two formula, most common formula, are the Chezy and the Manning formula, is applicable to solve this kind of the problems. This is the Chezy equation. The velocity can be calculated by C under root RS. V is the velocity in the channel, and C is the coefficient, which is called the Chezy coefficient, depending on the material, yani the roughness of the channel, bottom, and also the type of the material. R hydraulic radius, which I have shown you already in the first slide, the A over P, area of the wetted parameter, and S is the slope of the channel from top to the bottom. There is a slope, so that is the S. You can apply this equation, you can solve for the velocity. If you want to calculate the Q, then multiply with the area. Q equals to A into V, you can get the Q also. So this equation is Chezy equation. I have already uploaded, I think, I already uploaded this problems of the unit 5. You can go over those problems, and you will understand how to apply this one. If there is any problem, I can explain you again. Manning equation. Similarly, like the Chezy formula, you calculate velocity here by this formula. By using Manning equation, you can calculate the velocity again. This also having the same R and S like in the previous equation, but the coefficient is different. In the previous formula, this is the Chezy constant. Here it is a Manning coefficient. So these are the two formulas which can be utilized to calculate the velocity and the Q. When you will use the Chezy formula, when you will use the Manning formula, based on the value of the coefficient is given to you. If N is given to you, you use the Manning formula. If C is given to you, you will use the Chezy formula. And as I told you, the N is also depending on many things: the type of the material, channel, variation, the shape, vegetation, flow condition. There are many things, and these values of the N is available in your book and any other textbook. So these are the different type of the pipe material, and these are the value of the N you can use in your calculation. So this is the Manning equation multiplied by the area. If you multiply by the area on both sides, it will become the Q. The same formula which I have shown you. And this factor, this 1 over n a r raised to power 2 by 3, this is a constant factor, right? So you can say that it is k, and the k is called as a conveyance factor, right? So this is the value of the k. So this formula can be written in this form, but most of the time we use the formula in this form to calculate the q and the v. This problem I have given you. Just go over that solution, see how the formula is utilized. If you know that meaning of each term, what is a, what is r, what is s, you can understand very easily, right? Otherwise, let me know, I will explain again. So this problem and these problems I have already uploaded. This one also, application of the Chezy constant, right? So it depends on what the constant is given to you, have to use that formula. Here you have to use the Chezy formula. This one, because n is given to you, have to use the Manning formula. Here again it is a Chezy formula. So based on the coefficient, you can select which formula you have to use. When we calculate the discharge in practically in an open channel, we use some devices to measure, right? We cannot measure the flow by calculating the how much volume is passing through that river per unit time, because it is a big cross section. So what we do, we put some a concrete structure on the way of the channel, the river or and other places, and these are called as the weirs. So weirs are concrete or masonry dam type of the structure built across an open channel like the river and canal, over which water flows, and we measure the Q on that. So this, for example, there is a water channel, so they put this structure, concrete one, and it having the V type of the structure. This is called as the triangular or the V notch, right? So this notch is helpful for our calculation of the Q. What we do when the water flow across this one, there is some height. Based on that height, we can calculate how much Q is there. I will show you how you can calculate the Q. This is another type of the weir or notch. It is a rectangular one. This is triangular one. So these are the most common weirs which we use. So the rectangular notch or weir is the same thing. Notch or weir having the formula to calculate. If it is a rectangular one, this is the formula to calculate the Q. If it is a V shape, then this is the formula for the Q. It's very easy. The B is simply the, for example, for the rectangle, it is the width of the channel. B, G, you know, constant, and H is simply the height. And you know that all these things are constant. In the river or in the structure, this is constant. So only with the change in the height in the water, you can calculate the Q. Same thing in the V notch. This is the H. Otherwise, this theta is known to us, right? And the G is known to us. We can calculate. And these formula again give us the theoretical Q. And you remember, like we did in the previous unit, the Q theoretical is actually by calculation, but actual Q is always lower than the calculated Q theoretical, because there are some losses. So what we have to do, we have to introduce a coefficient. This coefficient, if you multiply with this Q theoretical, we will get the actual Q. How much is the Q? So CD will always, you will see that it will be less than 1, because the actual Q is always less than the calculated Q. So these formula are applicable, very simple. In, for example, in this question, the width B is given to you, right? And the H is given to you, CD is given to you. So how you will calculate the Q? For example, in this one, B is given in this question, H is given in this question, you can calculate the Q theoretical. If CD is given to you, multiply with this CD, Q theoretical, which you calculated here, to get the Q actual. Similar are for the V notch and any other type of the notch. You can solve this problem. So just to go over this problem, I have uploaded this one, so check this one. These two problems, the similar way open channel by using the Chezy formula, Manning formula, right? This is for the Chezy formula, this for the Manning formula. Answer are there, solve yourself, try to find out the answer. If you do not get the answer, just let me know, right? So this is all about the open channel flow. If you have any question, you can ask me and we can discuss it again. Okay, thank you very much.